Tonight I want to have a conversation about this incredible global issue that's at the intersection of land use, food, and environment, something we can all relate to, and what I've been calling the other inconvenient truth. But first, I want to take you on a little journey. Let's first visit our planet, but at night and from space. This is what our planet looks like from outer space at nighttime if you were to take a satellite and travel around the planet. And the thing you would notice first, of course, is how dominant the human presence on our planet is. We see cities, we see oil fields, you can even make out fishing fleets in the sea. That we are dominating much of our planet, and mostly through the use of energy that we see here at night. But let's go back and drop it a little deeper and look during the daytime. What we see during the day is our landscapes. This is part of the Amazon basin, the place called Rondônia in the south center part of the Brazilian Amazon. If you look really carefully in the upper right-hand corner, you're going to see a thin white line, which is a road that was built in the 1970s. If we come back to the same place in 2001, what we're going to find is that these roads spurred off more roads and more roads after that, at the end of which is a small clearing in the rainforest where there are going to be a few cows. These cows are used for beef. We're going to eat these cows. And these cows are eaten basically in South America, in Brazil and Argentina. They're not being shipped up here. But this kind of fishbone pattern of deforestation is something we notice a lot of around the tropics, especially in this part of the world. If we go a little bit further south in our little tour of the world, we can go to the Bolivian edge of the Amazon, here also in 1975. And if you look really carefully, there's a thin white line through that kind of scene, and there's a lone farmer out there in the middle of the primeval jungle. Let's come back again a few years later, here in 2003, and we'll see that that landscape actually looks a lot more like Iowa than it does like a rainforest. In fact, what you're seeing here are soybean fields. These soybeans are being shipped to Europe and to China as animal feed, especially after the mad cow disease scare about a decade ago, where we don't want to feed animals animal protein anymore because that can transmit disease. Instead, we want to feed them more vegetable protein. So soybeans have really exploded, showing how trade and globalization are really responsible for the connections to rainforest and the Amazon. Incredibly strange and interconnected world that we have today. Well, again and again, what we find as we look around the world in our little tour of the world is that landscape after landscape after landscape have been cleared and altered for growing food and other crops. So one of the questions we've been asking is how much of the world is used to grow food, and where is it exactly, and how can we change that into the future, and what does it mean? Well, our team has been looking at this on a global scale using satellite data and ground-based data kind of to track farming on a global scale. And this is what we found, and it's startling. This map shows the presence of agriculture on planet Earth. The green areas are the areas we use to grow crops, like wheat or soybeans or corn or rice or whatever. That's 16 million square kilometers worth of land. If you put it all together in one place, it'd be the size of South America. The second area in brown is the world's pastures and rangelands where our animals live. That area is about 30 million square kilometers, or about an Africa's worth of land. A huge amount of land, and it's the best land, of course, is what you see. What's left is like the middle of the Sahara Desert or Siberia or the middle of a rainforest. We're using a planet's worth of land already. If we look at this carefully, we find it's about 40% of the Earth's land surface is devoted to agriculture, and it's 60 times larger than all the areas we complain about, our suburban sprawl and our cities where we mostly live. Half of humanity lives in cities today, but its 60 times larger area is used to grow food. So this is an amazing kind of result, and it really shocked us when we looked at that. So we're using an enormous amount of land for agriculture, but also we're using a lot of water. This is a photograph flying into Arizona, and when you look at it, you're like, what are they growing here? It turns out they're growing lettuce in the middle of the desert using water sprayed on top. Now, the irony is that's probably sold in our supermarket shelves in the Twin Cities. But what's really interesting is this water's got to come from someplace, and it comes from here, the Colorado River in North America. Well, Colorado on a typical day in the 1950s, this is just not a flood, not a drought, kind of an average day, looks something like this. But if we come back today, During a normal condition to the exact same location, this is what's left. The difference is mainly irrigating the desert for food or maybe golf courses in Scottsdale. You take your pick. Well, this is a lot of water, and again, we're mining water and using it to grow food. And today, if you travel down further down the Colorado, it dries up completely and no longer flows into the ocean. We've literally consumed an entire river in North America for irrigation. Well, that's not even the worst example in the world. This probably is, the Aral Sea. Now, a lot of you will remember this from your geography classes. This is in the former Soviet Union, in between Kazakhstan and Uzbekistan, one of the great inland seas of the world. But there's kind of a paradox here because it looks like it's surrounded by desert. Why is this sea here? The reason it's here is because on the right-hand side, you see two little rivers kind of coming down through the sand, feeding this basin with water. Those rivers are draining snowmelt from mountains far to the east, where snow melts, it travels down the river through the desert and forms the Great Aral Sea. Well, in the 1950s, the Soviets decided to divert that water to irrigate the desert to grow cotton, believe it or not, in Kazakhstan, to sell cotton to the international markets to bring foreign currency into the Soviet Union. They really needed the money. Well, you can imagine what happens. You turn off the water supply to the Aral Sea, what's going to happen? Here it is in 1973, 1986, 1999, 2004, and about 11 months ago. It's pretty extraordinary. Now, a lot of us in the audience here live in the Midwest. Imagine that was Lake Superior. Imagine that was Lake Huron. It's extraordinary change. This is not only a change in water and where the shoreline is, it's a change in the fundamentals of the environment of this region. Let's start with this. The Soviet Union didn't really have a Sierra Club, let's put it that way. So what you find in the bottom of the Aral Sea ain't pretty. There's a lot of toxic waste, a lot of things that were dumped there that are now becoming airborne. One of those small islands that was remote and impossible to get to is the site of Soviet biological weapons testing. You can walk there today. Weather patterns have changed. 19 of the unique 20 fish species found only in the Aral Sea are now wiped off the face of the earth. This is an environmental disaster writ large. But let's bring it home. This is a picture that Al Gore gave me a few years ago that he took when he was in the Soviet Union a long, long time ago, showing the fishing fleets of the Aral Sea. You see the canal they dug? They're so desperate to try to kind of float the boats into the remaining pools of water, but they finally had to give up because the piers and moorings simply couldn't keep up with the retreating shoreline. I don't know about you, but I'm terrified that future archaeologists will dig this up and write stories about our time in history and wonder, what were you thinking? Well, that's the future we have to look forward to. We already use about 50% of the Earth's fresh water that's sustainable, and agriculture alone is 70% of that. So we use a lot of water, a lot of land for agriculture. We also use a lot of the atmosphere for agriculture. Usually when we think about the atmosphere, we think about climate change and greenhouse gases, and mostly around energy. But it turns out agriculture is one of the biggest emitters of greenhouse gases too. If you look at carbon dioxide from burning tropical rainforest, or methane coming from cows and rice, or nitrous oxide from too many fertilizers, it turns out agriculture is 30% of the greenhouse gases going into the atmosphere from human activity. That's more than all our transportation, it's more than all our electricity, it's more than all other manufacturing, in fact. It's the single largest emitter of greenhouse gases of any human activity in the world. And yet we don't talk about it very much. So we have this incredible presence today of agriculture dominating our planet, whether it's 40% of our land surface, 70% of the water we use, 30% of our greenhouse gas emissions. We've doubled the flows of nitrogen and phosphorus around the world simply by using fertilizers, causing huge problems of water quality from rivers, lakes, and even oceans. And it's also the single biggest driver of biodiversity loss. So without a doubt, agriculture is the single most powerful force unleashed on this planet since the end of the Ice Age. No question, and it rivals climate change in importance, and they're both happening at the same time. But what's really important here to remember is that it's not all bad. It's not that agriculture is a bad thing. In fact, we completely depend on it. It's not optional. It's not a luxury. It's an absolute necessity. We have to provide food and feed and, yeah, fiber and even biofuels to something like 7 billion people in the world today. And if anything, we're going to have the demands on agriculture increase into the future. It's not going to go away, it's going to get a lot bigger, mainly because of growing population. We're 7 billion people today, heading towards at least 9, probably 9.5 before we're done. More importantly, changing diets. As the world becomes wealthier, as well as more populous, we're seeing increases in dietary consumption of meat, which take a lot more resources than a vegetarian diet does. So more people eating more stuff and richer stuff, and of course, having an energy crisis at the same time, where we have to replace oil with other energy sources that will ultimately have to include some kinds of biofuels and bioenergy sources. So you put these together, it's really hard to see how we're going to get to the rest of the century without at least doubling global agricultural production. Well, how are we going to do this? How are we going to double global ag production around the world? Well, we could try to farm more land. This is an analysis we've done where on the left is where the crops are today. On the right is where they could be based on soils and climate, assuming climate change doesn't disrupt too much of this, which is not a good assumption. We could farm more land, but the problem is the remaining lands are in sensitive areas. They have a lot of biodiversity, a lot of carbon, things we want to protect. So we could grow more food by expanding farmland, but we better not, because it's ecologically a very, very dangerous thing to do. Instead, we maybe want to freeze the footprint of agriculture and farm the lands we have better. This is work that we're doing to try to highlight places in the world where we could improve yields without harming the environment. The green areas here show where corn yields, just showing corn as an example, are already really high, probably the maximum you could find on Earth today for that climate and soil. But the brown areas and yellow areas are places where we're only getting maybe 20 or 30% of the yield you should be able to get. You see a lot of this in Africa, even Latin America, but interestingly, Eastern Europe, where Soviet Union and Eastern Bloc countries used to be, is still a mess agriculturally. Now, this would require nutrients and water. It's going to either be organic or conventional or some mix of the two to deliver that. Plants need water and nutrients. But we can do this, and there are opportunities to make this work. But we have to do it in a way that is sensitive to meeting the food security needs of the future and the environmental security needs of the future. We have to figure out how to make this trade-off between growing food and having a healthy environment work better. Right now, it's kind of an all or nothing proposition. We can grow food in the background, that's a soybean field, and in this flower diagram, it shows we grow a lot of food, but we don't have a lot of clean water, we're not storing a lot of carbon, we don't have a lot of biodiversity. In the foreground, we have this prairie that's wonderful from the environmental side, but you can't eat anything. What's there to eat? We need to figure out how to bring both of those together into a new kind of agriculture that brings them all together. Now, when I talk about this, people often tell me, well, isn't blank the answer? Organic food, local food, GMOs, new trade subsidies, new farm bills. And yeah, we have a lot of good ideas here, but not any one of these is a silver bullet. In fact, what I think they are is more like silver buckshot. And I love silver buckshot. You put it together and you've got something really powerful, but we need to put them together. So what we have to do, I think, is invent a new kind of agriculture that blends the best ideas of commercial agriculture and the Green Revolution with the best ideas of organic farming and local food and the best ideas of environmental conservation. Not to have them fighting each other, but to have them collaborating together to form a new kind of agriculture, something I call terraculture, or farming for a whole planet. Now, having this kind of conversation has been really hard, and we've been trying very hard to bring these key points to people to reduce the controversy, to increase the collaboration. I want to show you a short video that does kind of show our efforts right now to bring these sides together into a single conversation. So let me show you that. is that we face one of the greatest grand challenges in all of human history today, the need to feed 9 billion people and do so sustainably and equitably and justly, at the same time protecting our planet for this and future generations. This is going to be one of the hardest things we ever have done in human history, and we absolutely have to get it right. And we have to get it right on our first and only try. So thanks very much.